So we have one more section to cover in Chapter 3. It's Section 3.3, and the title is Proving Lines Are Parallel. Now don't panic, we're not actually going to write any formal proofs. We decided not to do that this year. But we have some theorems that we've learned that if we were writing proofs we could use. And we've already talked about them in Section 3.2, the ones on the left here. We said we learned that if lines are parallel, then certain angle relationships exist. And so this double line symbol here, right there, that's a way of saying parallel. And I think we've used that in the past, but maybe we haven't. But that's a way of using a shortcut notation for saying things are parallel. So we have a few ways of knowing lines are parallel, right? We used to, in our examples in section 3.2, we would put an extra set of arrows on our line, like this maybe, and maybe a double set, maybe a single set. So this notation means parallel right there. But in this section, we're not using a diagram, so we're going to use just kind of a shorthand notation. And so those double lines also mean parallel, all right? So what we have happening here on this left side is that if we have parallel lines, we could say that corresponding angles are congruent. We could also say alternate interior angles are congruent, alternate exterior angles are congruent. And also if we had parallel lines, we knew that same side interior angles were supplementary. This is all stuff we talked about in section 3.2. And if we were doing proofs, this would be, all of this stuff here would be that shorthand notation I would allow you to use on a proof. So again, we're not going to do proofs, but in example 1, we're going to talk about which one of our theorems we would actually use if we were going to do the proof. But you're going to notice in the pictures down below, we don't have any parallel line markings, right? We don't have any extra set of arrows on any of our lines. None of these lines have that. So the question is, are the lines that are labeled with an A and a B, are they parallel? And so you're not going to use the theorems like we have on the left. We're going to use the theorems like we see on the right instead. So right here that I just pointed at in purple. The word converse, remember we learned that word converse. It means we're just going to change the order of the theorems on the left that I pointed at in red. So if we just flip those and change the order of them, it says that if we knew we had corresponding angles, then we would know the lines were parallel. Or if we knew we had alternate interior angles, then we would know the lines were parallel. If we had alternate exterior angles, that would make the lines parallel. I'm sorry, I'm actually saying that wrong. I'm forgetting about saying the word congruent. So if we knew we had corresponding angles that were congruent, then we have parallel lines. If we knew we had alternate interior angles that were congruent, then we would have parallel lines. If we knew we had alternate exterior angles that were congruent, then we'd know we have parallel lines. And if we had same side interior angles that were supplementary, that would indicate that the lines are parallel. So in example 1, it says, is it possible to prove that the lines A and B are parallel? And so if you have any of these things happening here in purple, if you have any of those things happening, then yes, your lines are parallel. So again, remember that's what this arrow says. It means then, right? So if you have any of the hypotheses coming true, then the conclusion of the lines being parallel will be true. And so if you look at example 1a, those angles, the 52 and the other 52, those are alternate exterior angles. And they are congruent. They're both 52. And so since my alternate exterior angles are congruent, then the lines must be parallel. And so it says, is it possible? If so, then provide the justification. So yes, it's possible. And the justification is if we have alternate exterior angles, and I'm going to abbreviate that, that indicates that the lines are parallel. So that would be our justification. Now, I probably should have put another example here. Maybe next year I'll change these notes. So if I had something like this with some alternate exterior angles in it, and maybe one of them was 52, but the other one down here was 48, then the answer would be no, the lines are not parallel because we don't have alternate exterior angles that are congruent. So always pay attention to if the angle pairs we learned about in section 3.2, if they are following the pattern that they're supposed to be following, meaning are they congruent or same sides, are they supplementary, then we definitely have parallel lines. All right, in example 1B, they kind of flip that picture sideways on me, but I do have a set of same side interior angles. 95 plus 85, if you added up 95 and 85, you would get 180 degrees. Therefore, I do have a set of same side interior angles. So the first question was, is it possible to prove them parallel? The answer is yes, it's possible. What's the justification? Well, I have a set of same side. So if I have a set of same side, I'm going to abbreviate, interior angles that are supplementary, which I do because 95 and 85 make 180, then I know I have parallel lines. So that would be my justification. All right, in C, they're communicating with markings instead of with measurements. So we know what those are. We've learned those in chapter, oh gosh, what was it now, 2 or 1? We know that these things right here that I'm highlighting in purple are called arc marks because they have the same marking on them. That means they're congruent. So we have a set of corresponding angles in picture C that are being marked as congruent because they have the same kind of arc marks on them. And so again, is it possible to prove that the lines are parallel? Yes, because if we have corresponding angles that are congruent, which we do in this picture, let me not rush too much. Oh my goodness, I forgot the word congruent up at the top here. Sorry, it's kind of getting late tonight and I'm just forgetting things. All right, so sorry, in example 1A, I should have said if our alternate exterior angles are congruent, that means we're parallel. And so same with example C here. If corresponding angles are congruent, that indicates that the lines are parallel. All right, so determine what kind of angle pair relationship you have happening in your picture. And if it's one of the types we learned about in section 3.2 and it's holding true, then you're going to have those parallel lines. All right, in D, hopefully you recognize those as vertical angles. And vertical angles were learned about in chapter 1, and they had absolutely nothing to do with parallel lines. In fact, remember what I said in section 3.2. We don't even need line B, right? It's not even helping us create 95 and 95. Therefore, we can't even possibly talk about the fact that B is congruent, parallel to A, because we don't even know anything about B right now. 95 isn't over there by that B. And so in this problem, no, there's no way we can say that lines A and B are parallel because vertical angles do not prove parallel lines. If you go up to the top here, none of those theorems that we have summarized at the top have anything to do with vertical angles. And so we will stop by saying no because there's no justification that we can come up with. Vertical angles do not prove that lines are parallel. So that one we'll say no because it said only tell us the justification if we know that the lines are parallel. All right, finally in example 1E, this 104 and the 76 that's no kind of relationship we've learned about. Those are not alternate interiors because the 76 would have to be over here if it was an alternate interior. It's not corresponding. If it was corresponding, we'd need an angle over here, right? We'd need one in the same relative position as the 104. So in this picture, I actually don't have an angle relationship that I learned about in section 3.2. But if I look at the fact that they gave me a 1 over here, I'm kind of thinking, why did they do that, right? The reason they did that is because we do have a linear pair happening along line A. And linear pairs, all they need is a straight line to exist. So I can use the fact that I have a linear pair and figure out that my missing angle right next to my 104 is a 76. And so if I were writing a proof, this proof would have several steps. The first step would be to prove that I had another 76-degree angle because of my linear pair. And then I could say that my corresponding angles are now congruent, right? The 76s are a set of corresponding. So in this problem, if I were writing a proof, it would take several steps, but the final answer would be that yes, A and B are parallel. And the reason why is because I have a set of corresponding angles that are congruent. So if I have these corresponding angles that are congruent, that's going to give me those parallel lines. All right. So again, that one took a little bit of work. We had to use that linear pair that was happening in the picture, but ultimately what ended up showing that the lines were parallel were one of the new sets of angles we learned about in section 3.2. All right, what else could we do with that? Well, this is going to feel kind of similar to 3.2, but again, notice that lines U and V in example 2, which I spelled example wrong, do not have the parallel markings on them. So it says find the value of x that makes the lines parallel. Well, if the lines were going to be parallel in example 2a, then those two sets of angles would have to be congruent because, again, these are corresponding angles, and they're only congruent if I have parallel lines. So I have to figure out what could I plug in for x that would make it equal, that 13x plus 6 would be equal to the 110. So set these equal to each other and figure out what is x. So subtract 6 off of both sides, and you get 13x equals 104. And then divide by 13. And you'll get x equals 8. So if x was equal to 8, if you plug that in, 13 times 8 plus 6, right, you'd get another 110 right here. And that would force those corresponding angles to be congruent, and therefore that would force U and V to be parallel. In example 2b, we have some same side interior angles. And remember, they're not necessarily supplementary unless U and V are parallel. So again, this is asking, well, what would force U and V to be parallel? Well, if these same sides ended up being supplementary. So let's figure out what would make them supplementary by adding them up and setting them equal to 180. So we end up getting x plus 186 equals 180. If you subtract 186 from both sides, you'll get x equals negative 6. So if x were negative 6, then I would have a set of supplementary angles, and since they're same sides, that would force U and V to be parallel. So we'd have negative 6 plus 71, which gives me a 65 degrees right here. And 65 and 115 do make 180. And again, that would force, it looks weird the way I put it. Let me put it up here. This would be 65 degrees. And since those angles are same side interiors, if they end up being supplementary, that makes the lines parallel. So it almost feels the same as what we did in 3.2. It's just a slightly different twist on the same information.